Here you can see the circle, and I have like all correct. I have two resistors here, R1 and R2. Decide the timing interval for the charging and discharging cycles of capacitor C1. The frequency of oscillation depends on the values of R1, R2, and C1. C1 here, and the speed of charging and discharging can affect control the oscillation frequency. The VCC is the positive power supply. It's 5 voltage here, and is here. This one is the LM55 timer C. When the power is supplied, it continuously switch its output between high and low states at a frequency determined by R1, R2, and C1. Here is the oscilloscope, and when I run the circuit, we can see a continuous square wave here, and the function of the circuit is the 55 timer IC. It can provide a continuous square wave without any external triggering. This type of circuit can used in flashing lights. And prior to the square wave, we can also know the frequency and the duty cycle. I stopped and and then this is the first line, it's the second one, and we have the time here. T2 minus T1 is 467.742 microsecond, and we use 1 write the number. We can know the frequency. The duty cycle is also we know the number, and we check this line. So we use this number T2 minus T1 and divide the number from here. Here is the duty cycle. And if we want to change the output frequency, according to the formula, we can know if we change the value of capacitor or the resistor, the frequency will change. And what is the voltage where channel 1 and channel 2 waveforms cross on the rising A? So rising A is from the blue line to the yellow line. So it's 1/3 multiple 5 VCC power, and the falling edge is 2/3 multiple 5 VCC power. And then we go to the part 2. Part 2 is here. We add a LED here and a transistor. The function of the transistor is it acts as a switch, and it can control the LEDs on or off, and also it was controlled by the LM55 timer output. And when the 55 output is high enough, the transistor will turn on and the battery will turn off. When it turns on, the current in the circuit, so the LED is on. When I run the circuit, you can see the LED flashes so quickly, and we know the formula, the frequency. If we want to change the frequency, we can change the value of the resistor or the capacitor. Like if we change The 1K to 100. Also, I change this one to 100. So let me see. It also flash so quickly. And this time I changed the capacitor to 0.0014, and we can see now the LED flash is slowly, but we can see it changing. So we can change the frequency by the resistor and capacitor value here. And part 3 is the 7 segment decoder and driver. So I think it's here. The function of this circuit is it takes a clock input and counts the pulses. The 74393, this is a binary counter IC, and the output is the binary count. And this binary count will be translated by the 74 LIs for 7 IC into signals to drive a 7 segment display. And this number is a human readable format. When I run the circuit, oh no, each time I push down the button, it increased 1, 2, 3, 4, 5, 6, 7, 8. And the function of the 74393 IC is this IC is a binary counter IC, and it can change the 5 voltage electrical signal to the binary count. And the function of the 74LS for 7IC is it can translate the binary count to the signal that can drive a 7 segment display to show the decimal digit. And it's a we can see the digit here. 1, 2, 3, 4, 5, 6, 7, 8, and so on. And here is the last part. We add the 74LS13AD here, and LED, some resistor, VCC power. The function of this 74LS13D IC, we can see here we need 3 input here. So definitely is a 3 to 8 line decoder. It requires 3 binary input and that equals them to active one of the 8 outputs. So it means that anytime only one output being active. the overall function of the circuit is the beginning is to receive clock pulses and display the number of received pulses on a 7-segment display. The 74393 counter IC records the number of pulses and translates, so the output will be in binary form. The next step, the decoder IC 74LI47. It receives the binary output and controls the 7-segment display to display the decimal digits. And if the circuit includes multiple 7-segment displays, the decoder IC74LIS138, it is used to select an active specific displays, and the different numbers can be displayed on each display, forming a multiple digit display. And let's stop this one. And when we run for this one, you can see push down button. The 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 decimal digit changes and also the LED changes, and only one lights on for any time.